Fish can become addicted to drugs flowing into rivers with sewage. Research conducted by Czech scientists suggests that fish may become addicted to drugs that end up in waters with sewage. This may cause their behavior to change. But aquatic organisms are exposed not only to drugs, but also to a whole range of drugs, from painkillers to antidepressants. Hundreds of millions of people around the world use drugs every year. It is easy to forget about a very basic biological principle. Whatever a person consumes, he or she must also excrete. For this reason, sewage is literally flooded with drugs and other chemical components excreted from the body. Wastewater treatment plants do not filter out similar chemicals because they are not designed to do so. Often, sewage is also discharged untreated into rivers and coastal waters. After entering the environment, drugs, medicines and their byproducts may affect wild animals, say experts in the Journal of Experimental Biology. In a recent study, scientists from the Czech Republic examined how methamphetamine, an increasingly popular drug around the world, could affect wild brown trout. Experts decided to check whether this drug could be detected in fish brains. This mainly concerned rivers where the concentrations of illegal substances had already been tested. It was also checked whether the amount of the drug detected was sufficient to cause the animals to become addicted. The trout were exposed to the drugs in large tanks for 8 weeks. Then they were transferred to clean waters for 10 days. The researchers tested the fish's preferences for choosing contaminated or clean water and compared them with the reactions of trout that had never been exposed to methamphetamine. Fish exposed to methamphetamine preferred water containing the drug. No similar preference was demonstrated in fish from the control group. The researchers also found that trout exposed to the drug made fewer movements during the 10-day withdrawal period. Researchers interpreted this as a sign of anxiety or stress. These are common signs of withdrawal in humans too. Typical chemical changes that occur in addicted humans also appeared in the brains of fish swimming in waters containing methamphetamine. Even after the drug was discontinued, these markers remained present in the fish. All this indicates that exposure of trout to methamphetamine may have long-term effects similar to those observed in humans. Why should we care that trout become addicted to drugs? There are several reasons. If, as recent research suggests, trout like drugs, they may be inclined to stay near pipes that discharge sewage. Previous research on various species confirms that fish can behave similarly to addicted humans. One of the hallmarks of drug addiction is a loss of interest in other activities, even those that are usually highly motivated, such as eating or reproducing. It is therefore possible that fish will begin to change their natural behavior, which will cause problems with their feeding, reproduction and ultimately survival. For example, they may be less likely to avoid predators. Exposure to drugs affects not only the animals themselves, but also their offspring. In fish, addiction can be inherited over several generations, resulting in long-lasting consequences for ecosystems even if the problem was solved now. This isn't the first study to find illegal drugs in wildlife. In 2019, scientists in the UK found cocaine in freshwater shrimp in all 15 rivers they sampled. Interestingly, they detected illegal drugs more often than some common drugs. The effects of drugs on ecosystems remain largely unknown. However, comprehensive studies have been conducted on the effects of pharmaceuticals on fish in rivers. Medicines are not fully broken down in our body. Their metabolites go along with urine and feces to sewage treatment plants and from there to rivers. Some pharmaceuticals enter waterways through seepage from landfills or agricultural fields, where human sewage is used as fertilizer. Wildlife living in rivers and coastal waters where sewage is discharged are exposed to a cocktail of drugs, from painkillers to antidepressants. Such fish can, for example, change sex from male to female in a matter of weeks due to exposure to endocrine-disrupting chemicals found in birth control pills. Recent studies have also shown that antidepressants can cause behavioral changes in aquatic organisms, such as aggression or increased boldness. Fighting against drugs that end up in the environment can be very expensive. One study estimated that it would cost more than $50 billion to upgrade sewage treatment plants in England and Wales to remove these harmful chemicals. It may seem obvious that both legal and illegal measures designed to change human behavior also change the behavior of wild animals. However, this problem is much more complex. It is not even known whether synthetic chemicals contained in everyday products such as cosmetics, clothing and cleaning products can influence the behavior of humans and other species. An international group of scientists has called on companies and regulators to check their toxic effects on behavior as part of their risk assessment of new chemicals. The world is far from solving the problem of addiction and illegal drug use. But we can do more to improve filtration in sewage treatment plants, say researchers. The Mediterranean diet has a positive effect on our brain. Obesity negatively affects many organs in our body. This also applies to the brain, which results in the acceleration of its aging processes. But this can be remedied. Scientists in Israel have found that following a diet rich in vegetables, fruit, fish and whole grains, such as the Mediterranean diet, and losing weight with it can slow the signs of accelerated brain aging. We are what we eat. And this also applies to our brain, the condition of which we can take care of with an appropriate diet. Recent research shows that the Mediterranean diet has a particularly beneficial effect on it. What's more, it can even influence his biological age. The description and results of the research were published in the journal, eLife. Studies in which the chronological age of the brain was estimated based on neuroimaging showed accelerated aging of the organ in people with obesity. However, until now it was unclear how this estimate would be affected by weight loss following diet and lifestyle changes. There can be a significant difference between chronological and biological age. Chronological age is counted from the date of birth. Biological age is determined by the aging of body functions. Age reflects the health of a person's cells and tissues and can be influenced by disease, lifestyle, environmental factors, and more. We have no influence on chronological age. But we can influence biological age. To some extent, we even have the opportunity to reverse these unfavorable processes. And one of the ways to do this is a proper diet. The key to success is to eat as little processed products as possible while ensuring that our diet includes enough vegetables, seafood and whole grain products. The result of following such recommendations is weight loss and slowing down the aging process of the brain. When the brains of people who followed the Mediterranean diet for 18 months were scanned, it was found that they appeared to be as much as 9 months younger than what was expected in terms of the chronological age. 102 people took part in a detailed study on the impact of this diet on brain health. In each of these people, magnetic resonance imaging of the brain was performed both at the beginning and after 18 months. Their liver function, cholesterol levels and body weight were also examined. During these 18 months, participants followed one of three diets: a Mediterranean diet with plenty of nuts, fish and poultry instead of red meat, a Mediterranean diet with supplements such as green tea, and a healthy diet based on available recommendations. However, their brain age was estimated using an algorithm, trained on 300 people, which precisely made such estimates based on the connections existing in the brain. On average, all study participants lost approximately 2.3 kilograms. It was estimated that up to 1% weight loss resulted in a person's brain appearing approximately 9 months younger than their chronological age. Some evidence also suggested to scientists that the Mediterranean diet may have a positive effect on memory in older people. However, slowing down brain aging has also been associated, for example, with lower levels of liver fat. However, the study in question was affected by certain factors that may distort the results. First of all, it was mainly attended by men. Moreover, before it started, they completed online questionnaires in which they described their eating habits and lifestyle, so they could decide which information they would disclose. Moreover, as part of the research, everyone received free access to the gym. However, this does not change the fact that nutrition affects our health and, consequently, the health and functioning of the brain. Microplastics settle in the human respiratory tract. Global plastic production is increasing year by year. With it, environmental pollution with plastic waste, including microplastics, is increasing, which poses a threat to our health. In a recent study, scientists determined that tiny plastic particles become deposited in the human upper respiratory tract. Fluid dynamics simulations conducted by scientists from the University of Technology Sydney, Western Sydney University, Urmia University, Islamic Azad University, University of Camilla and Queensland University of Technology have shown how harmful plastic particles accumulate in the nasal cavity and back of the throat. The description and results of the research were published in the journal, Physics of Fluids. Scientists decided to look at the respiratory system and how microplastic particles behave in it. As we know, microplastic pollution is ubiquitous, and plastic particles have already been found in the soil, water and air in large quantities. Unfortunately, researchers do not have good news for us, because we also breathe microplastics. The analyses conducted showed that approximately 16.2 microplastic particles can reach human lungs per hour. In effect, it looks like we're inhaling one credit card a week. Unfortunately, these particles are often also toxic, which means that they can negatively affect our health. So studying how tiny pieces of plastic travel through our respiratory system is crucial. Therefore, a team of scientists representing several universities decided to take a closer look at this issue. For this purpose, a computational fluid dynamics model was developed to analyze the transport and deposition of microplastics in the upper respiratory tract. In this context, scientists decided to look at particles that differ in shape, spherical, cylindrical and tetrahedral, and size, 1.6, 2.56, and 5.56 micrometers. Different breathing rates were also taken into account. Generally, it has been noticed that microplastics tend to accumulate in warm places, such as the nasal cavity, middle throat and on its back wall. It should be emphasized here that where these particles are located in our upper respiratory tract is partly related to the structure of this part of our respiratory system, especially its asymmetry. As a result, they leave the main airflow line to land in these places. In terms of the effect of respiration rate and particle size, what was expected was found. First of all, faster breathing contributes to less microplastics being deposited in our upper respiratory tract. The largest of the analyzed molecules also remained in the mentioned locations more often than others. Scientists argue that their research highlights the importance of the problem, especially in regions where plastic pollution is high or in highly industrialized places. In the future, studies are planned on a much larger scale, which will include, among others, factors such as air humidity or temperature, and with individualized models, this time in relation to the lungs. Archaeologists have discovered an extensive network of roads dating back 4,500 years. Thousands of tombs line the routes. In what is now Saudi Arabia, archaeologists have discovered an impressive network of roads along which thousands of tombs have been found. These funeral avenues were created around 4,500 years ago. And the longest one is 170 kilometers long. Scientists called the ancient road network funeral avenues because there are tombs along each path. These routes in the early and middle Bronze Age connected oases and pastures over a wide area and led Bedouins and their animals through avenues surrounded by ancestral remains to the water. Discoveries of scientists from the University of Western Australia were published in the magazine, The Holocene. Funeral avenues were the main highway networks of their time. They show that the populations living on the Arabian Peninsula 4,500 years ago were much more socially and economically interconnected than previously thought, says archaeologist Matthew Dalton of the University of Western Australia. Scientists used satellite and aerial photos in their research, which allowed them to confirm the existence of a network of ancient roads. Then it was time for ground research and excavations. In total, the team located avenues in an area of 160,000 square kilometers. Over 17,800 tombs were discovered around the road network, of which approximately 11,000 lies in the immediate vicinity of paths, as if it were part of the funeral avenues. Stone-lined burial sites such as those found in what is now Saudi Arabia are quite common throughout the Arabian Peninsula. But in the northwestern part of the peninsula they are much more concentrated and plentiful. Researchers say the density of burials is unparalleled in any other excavation site. Most of the discovered tombs resemble an exclamation point or a keyhole from above. Scientists have noticed that the greatest density of tombs lies near water sources. These oases show some of the densest known concentrations of tombs anywhere in the world. The sheer number of Bronze Age tombs built around roads suggests that populations had already begun to settle permanently in favorable locations, Dalton admitted. Upon closer examination of individual oases, scientists identified a network of smaller paths radiating outward. They suspect they were probably used to move herds of animals during periods when rainfall was higher. Ancient paths lead to the tombs. Some of the roads were paved with red stone, but most were simply formed by the constant movement along the routes by people, and especially by the animals with them. A network of roads connects huge areas. By following these roads, people could travel a distance of at least 530 kilometers from north to south. There are also indications of a similar road network in the southern Arabian Peninsula. These require careful study, but may suggest further road networks covering even larger areas through which ancient populations moved. Archaeologists know little about the ancients who built this road network. They also know little about the tombs themselves found along the routes. The human remains found there are in poor condition, and some of the tombs have already been looted. An artificial leaf that uses sunlight to produce gas. Inspired by photosynthesis, chemists from the University of Cambridge have developed a device that uses sunlight, carbon dioxide and water to produce synthesis gas. Artificial leaf, as the machine was named by its authors, may become an alternative to fossil fuels in the future. Artificial leaf has huge potential that can be used in energy or transport. Cambridge scientists have demonstrated that they can directly produce synthesis gas in a sustainable and simple way. The invention of British scientists is at a very early stage of development, and a lot of work is still needed before the artificial leaf will power our households. If it ever happens. The results of 7 years of hard work by Cambridge scientists were published in the journal Nature Materials. Although the artificial leaf is powered by sunlight, its designers argue that it also works effectively on rainy and cloudy days, just like natural leaves. This means that this technology does not have the limitations faced by conventional solar panels and can be used not only in the summer months or in countries with high sunlight. It works perfectly from dawn to dusk anywhere in the world, said Virgil Andre, one of the study's co-authors. The device produced by Reisner and his colleagues is inspired by photosynthesis, a natural process in which plants use energy from the sun to convert carbon dioxide into food for themselves. Synthesis gas is currently produced from a mixture of hydrogen and carbon monoxide and is used in the production of fuels, pharmaceuticals, plastics and fertilizers. However, unlike industrial synthesis gas production processes, the artificial leaf does not emit additional carbon dioxide into the atmosphere. You may not have heard of syngas itself, but every day you consume products that are created using it. The ability to produce it sustainably would be a key step in closing the global carbon cycle and establishing a sustainable chemical and fuel industry, admitted Professor Erwin Reisner from the Department of Chemistry at the University of Cambridge, co-author of the study. The device uses carbon nanotubes with 2 light absorbers, similar to the sunlight-collecting molecules in plants, that are connected to a catalyst made of cobalt. Once immersed in water, a reaction begins in which one light absorber uses a catalyst to produce oxygen, while the other performs a chemical reaction to reduce carbon dioxide and water to carbon monoxide and hydrogen, creating a synthesis gas mixture. Synthesis gas is not as calorific as natural gas, so its combustion is not as efficient. The team of researchers is now looking for ways to use their technology to create a sustainable alternative to gasoline. Synthesis gas is already used as a component in the production of liquid fuels. What we would like to do next is, instead of making syngas and then converting it to liquid fuel, we would make liquid fuel in one step from carbon dioxide and water, Reisner said. While great progress has been made in generating electricity from renewable energy sources such as wind power and photovoltaics, Reisner says the development of synthetic gasoline is essential. There is a great demand for sustainable liquid fuels for heavy transport, shipping and aviation, he noted. Our goal is to sustainably produce products such as ethanol, which can easily be used as fuel, André said. Producing it in one step from sunlight using a carbon dioxide reduction reaction is difficult. However, we are confident that we are heading in the right direction and that we have the right catalysts. So we believe that we will be able to create a device that can demonstrate this process in the near future, he added.